Hi, my name is Phil Williams. I'm going to present about the Polysync system and how we were able to retrofit the Polysync system onto a blue roof that you would never really put a green or blue roof onto that roof. The Polysync system is a smart system that has been developed in collaboration with Kisters, Polypipe, EPG and Mashup Analytics. So what is Polysync? So basically the Polysync is a smart system. The purpose of that is whenever you do a new design, you have to put in your rainwater attenuation. That's managing the 100-year storm event plus 40 to 55% extra for climate change. And then if you wanted to harvest some of that rainfall, you have to put in another rainwater harvesting tank, because you have to assume that the rainwater harvesting tank is full when your 100-year storm event comes. So what the Polysync system does is it uses rainfall analytics to see the storms coming in and makes a decision about emptying out the water. So 99% of the time, a traditional attenuation tank is empty. What we're trying to do is make it full. Have it there for rainwater reuse, irrigation, flushing the toilets, because water is now going to be a critical resource for everyone. And then what it does when it sees the storm come in, it makes that decision. It sees how much rainfall is going to come in, makes the decision about how much water it should discharge. One of the benefits of doing it this way is it tends to harvest storms. The idea is when a storm comes in, it collects that storm, that storm, so it doesn't actually discharge to the sewers at capacity. So the idea is, rather from running from empty to empty, which a normal attenuation tank does, we're looking at running from full to full. So we're discharging ahead of the storm, collecting the water as the rainfall comes, and then at the end of the storm, the tank is full, ready for us to reuse it. But we've got a number of these smart systems out there. There's 3 or 4 of them. So what's the difference between, say, Polysync and some of the other ones? Well, one of the big things is its ability, its scalability, and it uses a digital twin and it uses optimization. So the purpose of the Polysync is it can work from an individual single tank, and it moves right the way through, and it's been programmed so it can talk with all other sensors, all of the levels, Brian's system out there possibly. So all this information can feed into the Polysync system, and it makes a decision. It uses it all, so it turns everything then into a smart system. So we're changing dumb assets into smart assets. So you can just have a single attenuation tank that may be brand new or retrofitted in, or as we're currently discussing in Jersey, maybe putting this in one of their reservoirs, so their reservoir becomes a main attenuation system for when this storm comes in. Anyone who's knows SUDS will see the 4 pillars of SUDS. So I've tried to replicate it with the 4 pillars or the foundations of SMART. So one of the most important things is the weather forecasting. Last week I was meant to be in Neath doing a site visit. It's a 4-hour drive, 5-hour drive from Warrington to Neath down the M6, which is a lot of fun. Tuesday night, getting amber weather alerts, yellow weather alerts, made a call, we're not going to go tomorrow. So I cancelled, I changed my alarm, had a nice extra 2 hours in bed, woke up, blue skies, it was wonderful. So I just looked literally like a liar. They've woke up to my email saying, because of the weather, I can't come, and it's lovely. So we need to, so the weather in the Polysync system is a blended approach. So it's not just the Met Office, it is all the weather forecasting information taken into one system, and then it's blended together using statistical engineering over the last 30 years. But as has been alluded to a number of times, it's still not perfect. There is still these flashy, big storm events coming. So this is where engineering comes in, building in fail-safes. What happens if this storm event comes and it's not even being predicted? Building in engineering. So engineering is critical. I'm speaking to a room full of engineers, so I think I don't need to play that side up. And another one is data and software. A few years ago, a big Las Vegas casino got taken for a couple of £1 million because someone got into their bank account via a wireless thermometer in a fish tank. So if they can do it that way, they can get into your building maintenance system or anything else that a smart system is connected to. So that is critical. We really need to improve, have that, all these areas locked down. So as the good doctor said before he did it, he's going much further into digital twins and smart and AI than us, but in the background of the Polysync system is a digital twin that is currently assessing the weather, seeing what's predicted, what's actually happening, and then revising the forecast, revising its optimization, revising when it should be discharging. So what we've done is, with United Utilities and Bruntwood, we move this from theoretical into a live demonstration. So we put it on the block roof. It is a former NatWest bank, incredibly lightweight roof. So the roof had 1 in 80 falls. If you went to anyone and said, "Can I put a blue roof on this?" they would say, "No, not a chance. You put a green roof on that, it will die the first time the sun comes out." So what we've done is using the smart system coupled with passive irrigation. So a blue roof, what it does is it has passive irrigation, rock wool tied into the cell cones. We could really thin down the substrate. So the usual substrate thickness is about 150. We brought that down to 75 mil because there was always a layer of water to provide that irrigation so it doesn't burn the first time the sun comes out. We used polyrend to level, we re-waterproofed the deck, used polyrend to level it out to plus or minus 10 mil. And then we installed the blue roof layer, which is permavoid. And if you're looking at the central picture or the image looking down, that is to the west of the block. That means that this area is in the rain shadow of a 13-story building. And it's Manchester, the predominant weather system is westerlies coming in. So this doesn't perform in the same way as a weather forecast would tell you to do it. So this is where the digital twin and AI actually comes in. What it's done is it's learned how the system works with whatever weather forecasting comes in. And then, as I said before, using the passive irrigation, we was able to really thin down our substrate, which is a lightweight lacquer type of substrate, to passively irrigate the system. This is how it looked. This was this time last year. It's glorious. It survived the 40-degree weather, which I was concerned about, but it survived it. And one of the things that we've been able to do is we dialed in the vegetation on the roof. So one of the key things that we needed to provide was a habitat for the blue butterfly. It was a butterfly that was thought to be extinct. We dialed in the vegetation. So this is a green area, a green oasis in the middle of Manchester for the blue butterfly. So we've got a year's worth of solid data of the system performing once it's been through its digital twin, it's actually optimized itself. So what we're currently doing is we're extracting all the data out from all the rainfall and seeing where are the 5 mil events. And then what difference does this make to the 5 mil events? How much water, if a 5 mil rainfall comes in, how much water do we discharge to the United Utilities sewer? What stands out, even before we've done that work, is the big events, it's harvesting. These graphs are essentially showing big events coming in, 10 mil, 20 mil worth of rainfall, and then it's not actually discharging. The blue line you're seeing dropping is the level of water in the tank, but it's not opening. What that is that's passive irrigation being used. It's collecting that storm. So these are big storm events which are causing flooding in the centre of Manchester, but it's not going to the sewers. It's being held and it's being recycled by the plants. So the future applications for the Polysync is to start building this out. We've got a number of new developments this is going into. What we want to be able to do is get them all talking to each other. The more times that they can talk to each other, the better the information is. What we want to also do is work with the water companies, have the water companies talking back to the Polysync system, saying, if you can put this in Manchester, say you've got the block roof, Arndale, the sewer turns around to the Arndale and says, you discharge for the next half an hour, block roof, you discharge for the next half hour, the following half hour, and have the discharge being determined by the sewers, by their capacity, rather than just an arbitrary, let's discharge a greenfield runoff rate. And hopefully by having that done, especially if you can determine, say, where it is, whether it's close to CSOs, you might be able to limit the flow discharge from the roofs or the outlets close to the CSOs, so the CSOs don't actually, it might be a way of mitigating against that CSO. So, thank you.